As you see, it's perfectly transparent, it's liquid, and very easily can be moved through the primary circuit and heat exchangers of the reactor.
Thus began Oak Ridge National Laboratory's 25 years love affair with molten salts.
There are several key advantages to a molten salt reactor, and they all trace back to the innate stability of the salt form. When two elements are formed as a salt, they're very chemically stable.
Yeah, there's nothing in the world more stable than fluorides or chloride salts. They're just impossible to kind of split apart. So they're very stable, like sodium chloride. Sodium is dangerous on its own, chlorine is dangerous on its own. Sodium chloride together is table salt. So they're just very stable entities to work with in general.
This allows them to operate at high temperatures and yet at low pressures. A nuclear reactor needs to operate at high temperatures in order to generate electricity, but it's undesirable to operate at high pressures because of safety concerns. Using molten salt as a fuel, on the other hand, it is possible to operate at very high temperatures, yet still at low pressures.
Nothing's trying to really burst out. You don't use water in the reactor so that there's no possible steam explosion. And there's nothing that can make a chemical potential. There's nothing that can make hydrogen production, like unfortunately we saw at Fukushima. Just really nothing that's going to push that out.
The work on molten salts and high-temperature materials attracted attention throughout the world.
私は東京大学の原子力工学科ができました時の第1回生です。それで直接の教授というかプロフェッサーム海坊という人が非常に溶融塩炉モルトソルトリアクターにね非常に強い興味を持っておられて講義でもそれは原子力材料学特論という大学院に入って第1回の講義がほとんど全部その溶融塩に関する講義でした。でそれはいずれその理想的な原子炉である溶融塩炉に変わるからもう君たちはしっかり溶融塩の勉強しなさいと。そういうふうに言われました。
Anyway, when John Kennedy became president in 1960, one of his first acts was to cancel the nuclear aircraft project.
It was decided that the idea of a large nuclear reactor flying around for hundreds of hours with a non-zero possibility of crashing was not all that good an idea. So they decided to cancel the propulsion of an aircraft with a nuclear reactor. The thing that really pronounced the death knell was advances in intercontinental ballistic missiles. As that capability advanced, the need for continuously flying aircraft diminished greatly. And that was a big factor in allowing the program to fade out.
That and common sense.
So ended the aircraft nuclear propulsion. Nevertheless, we felt that the molten salt for reactors was fundamentally a good idea.
And that ultimately led to the civilian program to look at molten salt technology for civilian applications.
Our goal with the molten salt reactor experiment, or MSRE, was to exploit the molten salt technology which was gained from the aircraft project to achieve the holy grail of nuclear development, a civilian reactor that would be both efficient and safe on its own.
There's a concept that at that time was called passively safe, passive safety. And the idea is that if you are driving a car, you know that you can always simply turn the ignition off and walk away from it, and it'll just be there. Well, with large, complex machines, that's not always true. And that's particularly not true for a nuclear reactor. If you, with the standard technology still generally in use in the United States, if you simply turn the reactor off, you have a problem because there's a huge amount of waste heat that needs to be dealt with. And under some circumstances, if it's not properly dealt with, this heat can itself cause the reaction to become more intense. That's what happened in the case of Chernobyl, which was a particularly delicate and sensitive instrument.
In the liquid fuel system, if it gets hotter, it expands and therefore is less dense, and that helps to control or, let's say, shut it down if the temperature goes too high.
The molten salt reactor has a nice characteristic that the fluid and the coolant is one medium. So you can always get rid of the fluid by letting it flow into fail-safe drain tanks below the reactor core.
Sid is going to show you.
Well, there are several drain tanks down there, and if there's a safety concern, like if you lose off-site power or power to all the equipment, there's a drain valve, they call it a freeze valve, that's normally kept frozen with salt in it. And on loss of power, the cooling goes away, the temperature of the salt goes up to the point where it's liquid, that's about 450 Celsius, and it automatically drains into one of these tanks, so it's safe from there on.
Now, what happens if there is a leak?
This is to show you what happens if molten salt is exposed suddenly to a region with much lower temperature, which means, for example, during a leak from a molten salt reactor or piping. As you can see, it immediately solidifies, which prevents any further and longer leaks out from the reactor.
This これに対して例えば、軽水炉というもので使っているような燃料ですと、これはウランの酸化物ですが、これが核分裂を起こしてかけらになります。でもちろんこれが燃料棒の被覆管というもので囲われているわけですが、これがもし破れるとこの放射性物質のゴミそのものが外に出てきてしまう。でこの場所でいても放射線を出しますが、これがどこかに行ってもそこで放射線を出す。またこれがあなたのところに行ってもそこで放射線を出す。もしこれが私の中に入るとこの中で放射線を出す。そういうふうに放射性物質そのものが外に動いていってしまう可能性があるというのが現状の燃料の特徴なんですね。そういった意味でもし事故が起こって原子炉が止まるような場合でもこの液体実際は固まってしまいますが、この中に放射線を出す放射性物質そのものが全部閉じ込められている、そういった意味で溶融塩炉に安全性が高いという特徴があるんですね。
The molten salt reactor began operation early in 1966 and achieved its maximum power in March of that year. Well, we were delighted with MSRE.
We were totally comfortable with the system. We typically walked around this area while the reactor, which is underneath here, was operating. There was no consideration of concern of some sort of untoward behavior. It was actually rather boring when the reactor was operating because there was nothing to do except sit in the control room and watch it run.
Later, it was revealed to the world that the Chinese had actually also started a molten salt reactor program in the early 1970s.
But I also want to tell you a story about the molten salt, why we choose molten salt. That back to 40 years ago, in the early 70s, and Shanghai, as a largest country of China, all of a sudden we are lack of supply of the coal. Because our coal plant here rely on supply of the coal from Shanxi province every day to have electricity generation. And all of a sudden the mayor realized the coal reserve only can last for 3 days. Otherwise the whole city will black out. No electricity. So the mayor went to Beijing to seek the help from the central government, and he met with Premier Zhou Enlai at that time. And Zhou Enlai told him, I can resolve the issue for the time being to guarantee you will have the coal supply for the next, a few months and so on and so forth. But in order to resolve the issue, finally, you have to start to look into the nuclear option. So the mayor of that time of Shanghai went back to city, and the first thing that we tried to build is molten salt reactor. It's not the water reactor.
And this had simply not been known outside of China, which was closed at the time.
We picked this as our priority to have a research on it is simply because it will be thorium-based, and thorium is the resources that China has the resources here.